Trucks carrying iron ore for the Croc Rock Mining Company arrive at a weighing station. The service time, T, per truck is defined to be the time elapsed from the moment the truck enters the station zone, including the time to be positioned and then weighed, up to the time it leaves the zone. It's known that the population mean, mu, is 80, and the population standard deviation is 20. 100 trucks are weighed. So the standard deviation is going to be 20 over root 100, which is 2. State the approximate distribution of the sample mean service time per truck. So that would be T bar, and that's going to be a normal with mean 80 and variance 2 squared. What's the probability the sample mean service time will be more than 83 seconds? So probability of T bar being more than 83. We can do that on the CAS. So go interactive, distribution, continuous, normal CDF. Now we're going for greater than 83. So we'll put the lower in as 83. And the upper, let's put that in as infinity. Now this is the standard deviation. Remember that was 2. And the mean is 80. And that's 0.0668. Okay. Suppose that more than 100 trucks were weighed at the Croc Rock weighing station. How would this affect your answer to part B? Explain without recalculation. Well, the standard deviation would be smaller because we divide by root n, and that implies the probability is smaller. And that's just because it changes the shape of the distribution. The distribution would be less spread out. Okay. It's desired that the probability of the sample mean service time will be between 80 and 82 seconds is greater than 40%. So that's the probability of T bar being between 80 and 82 is greater than 0.4. So to start with, let's consider the equal situation. So T bar being between 80 and 82 being equal to 0.4. Now, if we standardize here, so that we're dealing with Z, the standard normal, 80 was the mean. So for the standard normal, that's 0. And we don't know what this value is. That's what we're trying to find. And we can find that using the calculator, because this is the same as the probability of Z being less than K is 0.9. Remember, K is the mean, and we've got 50% down this side, so 0.5. So distribution, let's go for an inverse normal. Tail setting left, probability 0.9. Sigma is 1, mu is 0 because we're using a standard normal. And that gives me 1.2816. Now, think about what that K value actually is. 82, take away the mean, divided by the standard deviation, which is 20 over root n, that is the K value. So that's how we can find n. We can solve. Action advanced, solve. and we've got 82, take away 80, divided by 20 over root x is equal to 1.2816. That gives me 164.25. Well, that's the equal situation. We actually want a greater than, so we'll say n is equal to 165.